Hi everyone and welcome to the internet. So what we're going to be doing in our lesson today is having a look at the electrolysis of solutions. So hopefully by the end of this lesson you're going to be able to describe and explain what's actually happening when we carry out the electrolysis of a solution. So to start things off, as always, there's some questions on screen for you. So have a go at answering those 4 questions in your books. We got 4 questions there. I think that 3 minutes should be enough time for you to have a good go. So off you go. Let's check our answers then. So for number 1, the negative electrode is called the cathode. Give it a tick if you've got it right. The positive electrode for number 2 is the anode. Number 3, the electrolyte, is the compound in the liquid state or in solution which contains the mobile ions and therefore can also conduct electricity. So tick that one if you got it right. And then finally for number 4, what we needed to say here is something about the calcium ions being positively charged and therefore attracted to the negative cathode. And when they're at that cathode, they're going to gain electrons to become neutral atoms. We do the same thing for our chloride ions, pointing out that the chloride ions are negatively charged and therefore they're attracted to the positive anode, where they're discharged by losing electrons to become the neutral atoms. So add up your scores and let me know in the chat window how you did. What score did you get out of 4? Just stick a number over there now. So one of the really important things about electrolysis is the electrodes. Now, what we're actually looking at here is that we've got 2 types of electrode that we could have. And the one we're going to be focusing on today are the ones referred to as inert electrodes. And you can see the spelling of that on the screen there. Now, when we're talking about an inert electrode, these are ones that are going to remain unchanged throughout the process of electrolysis. So they're unreactive. Okay, so this is the key thing about the word inert. It means it doesn't react. So if you were to get a question on an exam paper asking you what inert means or why do we use inert electrodes, then it's all to do with the fact that they will not react with the solution. Now, in order to make these inert electrodes, then we have a choice of things that we can use here that are quite unreactive. We could use metals like copper or platinum because they're both unreactive metals, or we could use the substance graphite. So make sure you've got those points written down. I'll just give you another 10 seconds in case you haven't. So what we're focusing on today then is the electrolysis of a solution. Now, by its definition, a solution is where we've got a solute, so a solid, and we've dissolved it in water. So what we've actually got here isn't just our binary compounds that we looked at previously. We've got a chemical compound, but we've also got the water to contend with. Now, if we think about water first of all, then water itself becomes partially ionized. Now, what that means is that when we consider the water molecule, which you can see in the middle of the screen there, then some of the water molecules have become split apart to form hydrogen ions and hydroxide ions. So that's what we mean by partially ionized. Only some of the water has split to form those two ions. Now, what we actually find as a result of that then is that in any solution, then what we have are small concentrations of the hydrogen ions and the hydroxide ions. Now, what I want you to do first of all is there are 3 things for you to do at the bottom there. I want you to predict which ions move to which electrode. So which ions are going to the cathode, which ones are going to the anode. I want you to explain why you decided that. And then finally, I want you to suggest what substance we may form at each electrode. So what do we form at the anode? What do we form at the cathode? So I'm going to give you about 3 minutes to have those points written down and to have a go at answering those 3 questions. So write your answers in your books. I'll give you another 3 minutes to get that done. Okay, so as we've just said, the water has been split into hydrogen ions, which are positively charged, and hydroxide ions, which are negatively charged. Now, hopefully we remember that the cathode is the negative electrode, so it's going to attract the hydrogen ions because opposite charges attract. So the hydrogen ions are then discharged at the cathode, and what they will form at that point is hydrogen gas. So we'll be able to see these little bubbles of gas being given off at the cathode, and if we were to test it, we'd find it was hydrogen. If we consider the anode then, the positive electrode, then what we'll see here are the hydroxide ions being attracted, because the hydroxide ions, OH-, they've got a negative charge, so the opposite charges attract. And when the hydroxide ions are discharged at the anode, then they will form two things. We will still get little bubbles of oxygen gas, but we will also form water molecules. So make sure you've got those 2 points written down. I'll just give you another kind of 10 seconds if you haven't got those already. So let's look in a little bit more detail about the reactions happening at each of those two electrodes. So what I've given you at the top there, which I'd suggest you write down in your books, are the two half equations showing what's happening at the anode and at the cathode. So we'll start off at the top, which is going to be our hydrogen ions. So this is going to be taking place at the cathode. Now, what we've got are the hydrogen ions, H+, and they're in solution, so we put the state symbol AQ, which tells us it's in aqueous solution. And they are going to gain electrons, and an electron has the symbol E-. Now, once that happens, they're going to form hydrogen atoms, but remember what we said, we're forming hydrogen gas, which always goes around as a diatomic molecule. Diatomic, di meaning two, atomic atoms. So two atoms joined together. So you can see it's got the formula H2 with the little 2 in the subscript position. Now, what we actually find in order to have this balanced is it's going to be the 4 hydrogen ions, which then are going to join with 4 electrons, one for each hydrogen, and we're then going to be making 2 molecules of hydrogen gas. Then at the anode, the second one we can see there, we've got our 4 hydroxide ions, OH-, again, aqueous solution, so AQ is our state symbol, and when they reach the anode, they are going to form water, H2O, and water is a liquid, so we put the L in the brackets, and oxygen gas, so O2, because again it's a diatomic molecule, and in order to do that, they are going to lose those 4 electrons, one from each hydroxide. So what we've got there are the two balanced half equations for what's happening at each electrode. So what I want you to do next to those is jot down what kind of reaction is it at each electrode. Is it reduction or an oxidation? I want you to explain why you made that choice, and then write down how we could prove that we're making hydrogen and oxygen. So what do we do to test for those two gases? So I'm going to give you about 4 minutes to get that done, because I'm hoping there's going to be a little bit of detail in the last part at least. Okay, let's check to see you've got those right. Obviously, correct anything you didn't get right. Give yourself a tick if you did get it right. So at the cathode, where we've got our hydrogen ions, that is a reduction reaction, and the anode will be an oxidation. So give yourself a tick if you got those two correct. The reason for that is all to do with going back to that little phrase we use, oil rig. So oxidation is the loss of electrons. So we can see that for the anode, our hydroxide ions are losing electrons, so it's oxidation, and reduction is the gain of electrons. So we can see our hydrogen ions at the cathode are gaining electrons, so it's a reduction. In terms of how we can check to make sure we are making hydrogen and oxygen, it's the good old gas tests. Now, you should have done some of these way back at Key Stage 3, and hopefully we'll do them again when we're back in school. But to test for hydrogen, then we have a lit splint, and when we hold it in that tube, it makes a squeaky pop sound. And to test for oxygen, a glowing splint will relight. Tick them if you got them right, if not, jot them down. So the reason that we've actually looked to see what happens with water during electrolysis is because in this lesson we're really concerned with solutions, so where we've dissolved a solid in water. Now, any aqueous solution will contain the ions from that dissolved ionic compound, but it will also contain those hydrogen and hydroxide ions from the water. Now, what that tells us is it's not quite as clear cut as what we're going to make. So we've actually got competition at those electrodes because we will only discharge one ion at each electrode. And in this situation where we've got an aqueous solution, there's two competing ions there. So what we need to do is work out how we can then describe what's going to be made there. So make sure you've got those points written down. I'll just give you another 10 seconds in case you haven't got them yet. This bit here is really important. These are the rules, if you like, about how we work out what's going to form. So once you've written these down, highlight them, stick them in a box, do something that makes it stand out to you. Now, our first rule is that hydrogen will be produced at the cathode unless ions from a less reactive metal are present. If we have a less reactive metal than hydrogen present, then the metal is produced. In every other case, it will be hydrogen. For the anode, we will produce oxygen at the anode unless ions from an element in group 7, which are called the halogens, are present at a high enough concentration. In that situation, it will be the group 7 element being produced instead. So what we're really saying is your default answer can be hydrogen and oxygen, and then all we need to do is do that quick check. For the cathode, is there a metal that's less reactive than hydrogen present? If so, it's not hydrogen that's made, it's the metal. And for our anode, we just need to have a little look and see, is there an element from group 7 present? If there is, then it's that element made, not oxygen. So again, make sure you've got those written down, highlight them, do something to make them stand out, because this is critical to be able to answer these questions. So in order to actually work out what metals are less reactive than hydrogen, we need to know the reactivity series here. Now, the good news is you don't have to learn the whole thing, and you'll notice hydrogen there is in brackets in red. All you need to really do is remember the 4 metals beneath it: copper, silver, gold and platinum. Because if you know that those are the only 4 metals that are less reactive than hydrogen, then you can spot those. If they're there, they form. If it's any other metal, then it will be hydrogen that forms. So there's a quick way that you can learn that, obviously without learning the whole series. If you want to learn the whole series, by all means, feel free. But quick way, learn just the bottom 4. So if you need a bit more time to write that down, then by all means pause the video and get that bit done. What I've got here for you then is a table for you to have a go at completing, just to tell us what we're actually producing at the anode and the cathode. Now, I've filled out parts of it so you can see how to do this. On the far left, we've got our electrolyte. The next column along are the cations that are present. Then we've got the anions present. And then the last 2 columns are the product, so what we're making at the cathode and what we're making at the anode. If you look at the top line, I've done that one for you. So we start with copper chloride. So our cations are going to be the positive ions, remember. So we've got copper ions, and because it's an aqueous solution, we've got hydrogen ions. Then for the anions, the negative ones, we've got the chloride ion and the hydroxide ion. So when we're working out what we're making at the cathode, then that's going to be a case of, is copper less reactive than hydrogen? We've just seen, yes it is. So copper will be made at the cathode. Then for our anode, what we need to do is look and say, is there an ion from group 7 present? In this case, yes, we've got chloride ions, so we make chlorine. Have a go at finishing off the rest of that table. I'll give you a few minutes to have a go at this. If you still need a bit more time, pause the video now. So on the screen we've got the correct answers. As usual, tick any you've got right, correct anything you've got wrong. So I'm just going to give you a minute just to correct anything there. I won't talk you through the whole thing. If you still need more time to mark, obviously just hit pause for me. So last thing for you to have a go at today are our usual plenary questions. So up to grade 5 on the left, grade 5 and up on the right. So have a go at answering these in your book, and as usual you can get the answers on my website. If you still need more time to finish these off, just hit pause now. Don't forget you can get some additional questions and the answers to the plenary task on my website from the link on the screen now. Hopefully you found today's lesson useful, and I look forward to seeing you again in our next lesson on Friday.